We started. Okay.
Exactly.
And under that,
All right. I'll assume you finished popping since I heard some conversation and see so little writing. We have two separate topics today, economics and urbanization. I am not an economist, and so there's a lot of details here that go over my head. But so far what we can say here, so far within my notes I can lecture about. I got to tell you that environmental economics is becoming an increasingly popular field. As a matter of fact, you guys may know TJ Hamuz is a student at the school. He, for example, is going into environmental economics. I get a couple students every year that want to pursue this. And there's two separate questions that usually get stuck together. How much does your economy benefit from a healthy environment? And on the other hand, how much is your economy hurt by a degraded environment? You may know that, for example, schools are hurt by air quality. Does anybody know how that would work?
Sick children, like I said, I'm just taking kind of a guess here, but probably sicker children, less healthy children don't perform as well, maybe.
So academic performance is one thing.
Yeah, I don't get paid if the kids aren't in the seat.
And that's the other one. Bad air. Bad air, more sick students, more absences, less money for schools. Air pollution underfunds education. And you know, we actually have done the math on what percentage of student illness is caused by air quality. So we can start to attribute a certain percentage of economic resources for a school to clean air, or in the presence of unhealthy air, what that does overall for the amount of funding available to schools.
Wait, do you get deducted for every absence?
Yes. Yeah. Here's another one that I think most of you can probably follow. Air pollution makes people sick. Sick people do less quality work and work less hours. So, people have done studies on how much the United States gross national product is lowered by air quality. And we know that air pollution costs us about 3 to 5% of GNP. You can put a money value, whatever 3 to 5%, whatever our GNP is. What is it?
Like 15 trillion.
15 trillion is GNP?
Of GDP. GDP is about 15 trillion.
So about 15 trillion. So 5% of that would be 300 billion, is that right? 300 billion. Divided by however many Americans there are, is that 300 million?
Yeah, wow.
So that's exactly $1,000 of our gross domestic product per person lost to air pollution. That's actually like a pretty significant number. your per capita GDP on average nationwide suffers $1,000 per year due to air quality. So we could figure out what is all the air pollution that causes disease, and whoever makes that air pollution owes roughly $1,000 per person divided by the pollution. Yeah.
Is that just for education? Is that also factoring that we?
Sorry, I did different stuff. So first I was talking about education and attendance. Then when you were looking away, I did a little shell trip and started talking about gross domestic product, which would be total productivity and total economic activity. This is called economic valuation. And you should know that it's actually like a really tricky field. People get really pissed. You can imagine if you're a gasoline salesman and someone says, bro, your air pollution has cost $1,000 of my share of GDP, that you can imagine people will push back a little bit. So there's a lot of give and take and a lot of debate and a lot of peer-reviewed research and a lot of opportunities for new research to put money values on healthy environments or, on the other hand, money values on a degraded environment. You might also remember from the biodiversity unit the idea that our society benefits when the environment is healthy. Like we get clean air, clean water, more drinking water, better seafood, more firewood, more biodiversity, and biodiversity is useful for medicines, for food items, for industrial development. Did I tell you guys in the biodiversity unit about biomimicry?
No.
Key word, you may want to write it down, biomimicry. The idea is that things we see in nature inspire industrial development. There's a really classic example that I find totally awesome. There's this wacky fish called a cowfish. It's a type of tropical boxfish, which are related to puffers. Do you guys know that a part of the puffer fish has a toxin that you're not supposed to eat, and people prepare sushi out of it, and if you use the wrong part, it's called a teratotoxin. Have we talked about it? Have you guys heard about this? You're not supposed to eat pufferfish sushi? Okay. Yeah, right. So, there's this type of puffer fish called a cowfish. It's about that big. They don't get very large. It's like 2 boxes of matches stuck on top of each other. And they have a little tiny itty bitty mouth, 2 little itty bitty eyes, a giant forehead, and at the top of the giant forehead they have 2 little spikes that point forward like horns. And the fish is shaped like a fox, so there's 2 horns that point forward and 2 horns that point backward. And they have a little tiny tail and a little tiny fin. And they look like they're floating in the water. Their body doesn't move, just their fins. So the body looks perfectly stagnant, and their little tail goes, their little fingers. So they're really like a little horns. Yeah, they're really cute. You can see them at tropical saltwater aquariums. They're common in the fish trade. Cowfish. So Peter Gerson is a fish zoologist. And whoever the guy is, he was intrigued. Why did the fish develop these wacky horns? There's not a lot of fish that have horns. By the way, there are others, though. And so the dude trapped like 1,000 of these fish, and he plastinated them. Do you guys know what plastination is? You infuse plastic into the cells of the fish to turn it into a solid. So it won't rot. Have you guys ever seen those museum exhibits about the human body?
Yeah.
Where they remove the skin and they show you the musculature and they cut it into very thin slices and spread them out so you can see the. Have you guys seen this?
Yeah, it's really scary.
Awesome. And if you ever get a chance, it'll come back to Los Angeles next year, I think. You've got to go see the human body exhibit. Oh, cowfish picture? Cowfish. So this guy plastinates a cowfish, and you guys know how an air tunnel works?
Yeah.
You like put the thing in the air tunnel and you blow the air past it, and you can see the aerodynamic properties of that item. So you can do that in water. I don't think it's called a water tunnel. There's like another word for this. And so the guy gets all these plastinated fish, and he moves water with dye streaks in the water over the body of the fish, and he measures the eddies and the forces of the hydrodynamics of the fish. And they realize that if you snip the horns off the cowfish, it becomes less hydrodynamic. It takes more effort to move the fish without the horns, and thus, this zoologist writes a paper that says, the horns of the cowfish aid its efficiency. It can move through water using less calories because of the horns.
Why haven't all fish?
Yeah, those are them. Yeah, cowfish. They're really cute. You should look it up on your cell phone. Now everybody's looking up cowfish, right? Kind of neat. Yeah. This dude, before he published his paper, he called up his neighborhood Mercedes engineering, whatever they call it, product development office, and says, hey guys, I figured out a way to make your cars more fuel efficient. Would you like to consider my research? And they bought the science from the dude. Yeah, they bought his research, like really. So then, what? I have no idea. Yeah, they paid him $11. Anyway, they developed a small, lightweight, ultra-efficient car, and they figured out about 2 to 3% efficiency benefit by putting two little pointy parts on the front that are really small and hard to see, but two separate horns where you might have a spoiler. They put those two separate horns on the back corners of the top of the car. And as it turns out, the car was like super efficient. And how do the horns work? I don't know. They break up, eddy, something. I don't know. There's another classic example. Do you guys know that I think they are humpback whales, but it might be the gray whales on their dorsal fins, on the leading edge, they have little knobs, little bumps. Yeah. Somebody figured out that makes them more hydrodynamic, so now they're adding those onto winter money.
Yeah, we found that.
Okay, yeah.
Also, like sharks, on their skin, they have like what are called dermal ventricles.
Yeah, that's right. That makes them feel rough.
And like they actually discovered that when they swim, the little like skin films, they create like fortitudes.
Yep.
So like they make their water.
And this is why you can now buy shark skin suits for swimming.
That's like why they do shark skin.
That's right. That's right. The shark skin suit.
It like makes you slip through the water.
That's right. Cut down on resistance. Okay. It's really hard to speak over all these other conversations, so I'll move on. But remember, biodiversity offers us a lot of benefits. We might find a cure to cancer. We might find a way to make cars more fuel efficient. We might find a way to make swimmers swim faster. And Nike makes money, or Mercedes makes money from biodiversity. This is a discrete economic benefit of a healthy environment that we lose. We would probably not have invented these things from scratch if we didn't know where to find them in nature first. The last thing I want to talk about is number one, is the distinction between external and internal costs. Let's imagine I want to sell Daniel Pfeiffer 1 gallon of gasoline for $5 American US dollars. How did I decide to call this $5? What are my costs as Shell United States making this gallon of gasoline for Daniel? What am I paying with my $5? Extraction, refinery, distribution, transportation, labor costs, profit for my shareholders, profit for the guy who runs the gas station, research and development, advertising, whatever, right? That list that we all just mumbled, those are called the direct costs. They are internal to the price. And you could say that the price captures those costs.